Hello, this is James Cook, Assistant Professor of Social Science at the University of Maine at Augusta, and for an undergraduate social networks course, we're considering some aspects of social network design. If you ever have the chance and are really interested in issues of visualizing social networks, I strongly suggest you read a book by Sugiyama, Graph Drawing and Applications for Software and Knowledge Engineers. And if you're working with information describing relations, you are a knowledge engineer. It's a 2002 book, and you should see on your screen right now 2 pages from that, in which he describes different forms of visualization, not all of which involve typical sociograms, and some of which are matrices themselves, which can have visualizations in them. Over here on the left, you see his page 14, in which he describes a set of rules for the organization of social networks, so that people who are looking at these graphs, another term for sociogram, can look at them, easily understand what they are, what they represent, and what the patterns are within them. In his 2002 work, he comes up with a set of rules that seem pretty basic. Avoid overlapping edges. Avoid crossing edges. Make sure everything's on a straight line. Make sure that the ties between nodes are expressed as straight lines. Make everything symmetrical. Some of these assumptions work best when we're dealing with a graph that has a small number of nodes and a small number of relations in between. And one of the interesting things that has happened since 2002 is the explosion of what's called big data on social network relations. As the world has moved more and more onto the internet, it's become possible to mine data on the internet that describes how people are relating to one another in real time. You have a software tool at your disposal if you're taking my undergraduate social networks class, and that tool is NodeXL. If you've installed it, NodeXL is available in Windows by hitting the Windows Start key, which is a curvy window icon shape, and typing NodeXL XL template. We're going to go through an example today in which some of the rules that Sugiyama lays down are bent. And we're going to do that using online data. Now I'm going to hit the NodeXL tab up at the top, and I'm going to go to Import. You'll notice over on the left a large number of import options, ways to bring network data into the spreadsheet that contains edge lists, lists of vertices, and sometimes a picture of a network. Today we're going to focus on a Twitter search network. Twitter, for those of you who are not familiar with it, is a microblogging service in which individuals in 140 text characters or less express an idea. They use something that is often called a hashtag to denote a subject. So if I'm talking about giraffes and I write out a sentence and I want people who are looking for information about giraffes to find it, I would put a hashtag, a number sign, before the word giraffe, as I've done right here. And when I do that, it creates an automatic link. And so when people read my 140 character post on giraffes, they can click an automatic link that will appear in Twitter, and people can find all sorts of other posts in Twitter about giraffes, ones that use that term. It's called a hashtag. It's like a subject. I want to use a particular subject today, one called mepolitics. That's short for Maine politics. Okay, and I am looking for, if we look at the top, a vertex for each person whose recent tweet contains the hashtag mepolitics. I want to add a term in I want to make it recent. Let's make it within the last week. You'll notice if you look down at the corner of this screen, it will be since, well, now it's the 23rd of September, so let's make that since 2012. And I believe I'm using the right form, 09. What's 23 minus 7? 16, isn't it? Within the last week. I want to include connections. The connections are that one person can mention another person in a tweet. They do so, I'm going to show this text box. They do so using the @ symbol. And if they type in that Twitter account a name, like if your name was Suzanne Davis, and that was your account name, it would reference you. It would send a message to you in that 140 characters. Well, I'm interested in that. A mention, also a reply. As long as you do either, there's going to be a network tie between two Twitter accounts that's generated. I want to see what the structure of relations is in the last week for main politics. I'm going to very carefully, knowing in the past how many people have used main politics as a tag, I'm going to uncheck the limit to 100 people box. Be very careful when you do this. Twitter will only let you grab in so much information about searches within a 1 hour period. If you try to get too much information at once, it'll make you wait an hour. That's not pleasant for anybody. I want to add a tweet column describing what the tweets are. I want to expand the URL, which often is in a bit.ly form. I want it to unpack that and tell me what the real underlying URL is. A URL is a link to another web page. You can include those in Twitter posts as well, called tweets. And you can add statistics columns to the vertices worksheet to find out different sorts of information about who these people are. Now, I have a Twitter account. I've selected this before, and I've already authorized NodeXL to use that account to import Twitter networks. You have to do that. You have to have a Twitter account to use this feature. If you're interested in doing Twitter searches for this class and you don't already have a Twitter account, I encourage you to go to twitter.com and sign up for an account. You don't have to use it in order to do these searches. Also, that information is not widely shared, so you're not going to be losing a lot of privacy simply by signing up for an account. Whether you want to actually tweet to the world is another question, and that's wholly up to you. I'm going to hit OK, and I don't know what's going to happen. So let's see. Am I going to have to wait an hour to churn through a couple of cycles and get all the data, or am I going to get it all right away? Let's hit OK and see what happens. It's getting a list of tweets. We have a list down here. If this takes too long, I'll pause the video and we'll return to it. Well, hello. For once, I did have to pause the video because it wasn't quick. It took me about, 15 to 20 minutes to actually run that entire collection of information. But now I do have that NodeXL graph of all tweets using the hashtag mepolitics, short for main politics, in the last 7 days, from the 16th to the 23rd of September. Actual communications that are going on the web. So let's examine what we've got. We've got a set of vertices. And remember, our vertices only start at row 3, so we're going to subtract 2 to get the number of vertices by going all the way down to the bottom, hit Control and down arrow, and it'll take you down to the last one, which is 258. Subtract 2, and you have 256 vertices participating in tweeting behavior, microblogging, 140 character text messages out to the internet regarding main politics. How many connections are there? That is, mentions or retweets by those 256 nodes. There are 373 minus 2, 371 of them. 371 mentions and retweets. As you can see here in this particular example, there are sometimes particular Twitter accounts, particular users who are really engaged in a heavy conversation, taking up a lot of those edges. For instance, if we look at John Hink, who is in the state legislature, I believe, I should check that. There are, if I look at count, 58 tweets between him and an account called No Way, or a series of accounts called No Way. No Way is also engaged in writing on this track to All for Jury. All for Jury writes back to No Way. All for Jury writes back to John Hink. Oh, this is interesting. There's going to be some neat structure. Let's take a look at that structure. I'm going to show graph. Oh my goodness. Well, there certainly are a lot of dots there. Each of them is a node, a Twitter account. And now you'll notice some of those are what we would call isolates. They're making their own post that is not retweeted and that is not mentioned by another Twitter user. And, you know, perhaps other people read them, but they didn't respond, they didn't reply, there wasn't a conversation. There are other users, on the other hand. Let's find who's that one. Aha! John Hink. I find out because I click that, and all of a sudden these lines in blue that you see, light blue, are selected. They tell me John Hink is involved. He seems to be a very central figure in the main politics discussion. Why don't I go over and find out for sure who John Hink is? He's a Democratic candidate in 2012 for U.S. Senator. And he is a he is a member of the Maine House of Representatives. So I was right about that. I'm glad to hear that. And apparently he was running in 2012 for U.S. Senator from Maine, although clearly he is not now a major candidate for Senate. Those are being Angus King, Charlie Summers, and the Democratic candidate is Cynthia Dill. Let's head back to NodeXL. Always good to check up these facts. Let's think about how we might restructure this. Now, this was created using the Fruchterman-Reingold procedure for arranging nodes. Harel-Koren fast multiscale is another good one. Each of those is attempting to use a general principle, one that Sugiyama talks about, which is that nodes that are connected to each other should be close to each other, nodes that are not connected to each other should be farther away from each other, and nodes should have some kind of spacing with the most central nodes in the center of the graph. Okay, and that's just a different method for doing the same thing. Okay, we have a whole lot of what I suspect are isolates right here. I can select them. Oh, I can try to select just them and pull them out. And here's another set of what I believe are all isolates. Aha, not all of them are. Okay, so I'm going to try to find those individuals. There's one. I'll let him come back in. There's another. Let him come back in. And, oh, that's an isolate. What can I do? I can zoom in right in here. To try to identify those particular nodes that are isolates and that are not isolates. Why am I removing the isolates? Because they really aren't central to the graph. I'm arranging it. And yes, this sometimes can be a bit of a bear of a process, but I'm working through it. I'm moving them, I'm selecting them by dragging, and I'm moving them around until I finally get the few ones here that I believe are connected. Let's see. That's an isolate. That's an isolate. Not engaged in conversation with other Twitter users. One that is in there that is. Okay, so now I'm going to find that last. I believe there's just one more isolate in there. Maybe two. There it is. There's another isolate there. And I'm just going to continue on in this process, which is a little bit messy, but that's all right until I find those connected nodes again. And there are more elegant ways of doing this. There are less elegant ways of doing this. I'm doing the quick, relatively quick and dirty version of this. So you can see this takes a few minutes. It's not overly burdensome. Aha. There's the one. Now I'm going to zoom back out. And I'm going to move those few nodes, okay, that are isolates over here. I'm going to select them all, move them to the corner. I'll move these ones further to the corner, and then I'm going to do something special to them. I'm going to select them all, and I'm going to lock them there. I did a right click. Then I'm going to edit selected vertex properties, and I am going to look for the field locked, and I'm going to say yes. Now I can refresh my graph, because you notice I moved a lot of those other nodes around too, and I'm going to create again the Harrell-Cohen fast multiscale picture. Okay, it will do it differently a little bit each time, but each time it will use these design principles. The principles are that individuals who are tied to other individuals are close to one another. They're far away from other ones. There's a nice even spacing. And the most central individuals, the ones that are between others, are going to be laid out in the middle of the network. Okay, well, this is embodying some of the design ideas of Sugiyama, but I want to show you some options that might be a little bit different. You'll notice that this matrix has some trouble in the middle. It's very hard to tell who's interacting with whom in this very busy center. I can't follow those lines, can you? No, I can't. So I'm going to zoom back out. I can also use this slider. And I am going to right-click, and I'm going to go to Graph Options. I'm going to click on Edges, and breaking one of Sugiyama's rules, I am going to curve the lines. Let's see how that changes the way this graph looks. We're going to move to bundled in just a second. Now, this is still a little busy, but I'm going to tell you something. In the middle, we can begin to figure out which line is going where because the lines have many different angles. I can follow this curve from one node and trace it back to its origin. I wouldn't have been able to do that before because I wouldn't have been able to follow the suggested curve in the few places where things aren't so overlapped. And when you have a lot of nodes and a lot of lines, you will have overlaps. I can clearly do that from here. I can even do that in the middle here. I can go from one node and trace it back. Clearly that's not hitting the center, so it must be continuing to go forward, forward, forward. It comes from here. Let's see if I'm right. Yes, I was right. Okay, when I click the node, it shows me all of the associated lines. So I can do better than that even. Let's zoom back out. I can begin to make some different design decisions. Ones that say, you know, let's take a look at all of these nodes over here. You'll notice here that, that in the interactions that are made with this node and all these nodes, this is clearly a very popular node here, the Bangor Daily News, we find out it is. It's getting a lot of retweets of the tweet, Obama donations far outpace Romney's in Maine, and you'll notice the mepolitics hashtag. There are a whole bunch of other nodes that are doing the same thing. Couldn't we consider them to be very similar nodes, and mightn't we bundle them? Well, yes, we might. Let's do that. I'm going to right-click here again. I'm going to go back to Graph Options, and I'm going to bundle those. I could bundle them tightly. I could bundle them loosely by selecting an option here. Let's bundle them tightly. Let's see what happens. Boom. Now, all of a sudden, when we look at this network graph, we violated ostensibly Kozo Sugiyama's principle that says you don't do curves, you do nice straight lines, and you make sure they don't touch each other. Well, these ones do touch each other, but they're in bundles, kind of like bundles of cords behind your computer if you've put them together well, because they are all going to the same place. These are bundles of ties that start in one place and are all heading out to a similar region. It's saying that there's a large volume of ties coming in here to the central node, Bangor Daily News. That's useful. That's a principle of design, and it tells us something about the flow of information through this Twitter graph. Okay, next week you're going to get to start to play with this information too. I hope I've whetted your appetite, and we'll talk more about it next week. By all means, if you're interested in playing with this information, playing with the Twitter search function, finding out about some connections in discussions of, say, Maine politics, or politics in any other state, or discussions of knitting, go right ahead. Have fun. Explore. No one else is doing this right now on the whole internet, most likely for your particular subject, because there are very few people in the world who are looking at Twitter networks in this way in general. You could discover a new social fact, and you could do it this week. This is one of the exciting things about social network analysis. Okay, go to it.